talk about how to change the general form of the equation of a hyperbola into the standard form of the equation of a hyperbola, because this is the form that we want it to be in when we're graphing it. Now, remember, the general form of the equation of a hyperbola looks like this. In fact, all of our conic sections have equations that look like this when they're in general form. But if A and C have opposite signs, in other words, the coefficients of the x squared term and the y squared term have opposite signs, then we have the equation of a hyperbola. So we're going to transform it into an equation that looks like this. And notice these look almost identical, but in this one, the term with the x squared is first, and in this one, the term with the y squared is first. When we have a standard form of a hyperbola that looks like this, we have a hyperbola that opens right and left. And when we have an equation that looks like this, the hyperbola opens up and down. So let's jump in and try a problem. So here's the one we're going to do. The directions are to write this equation in standard form, and notice these are opposite signs, so in fact we do have a hyperbola. And then after that, let's just practice graphing, stating the coordinates of the foci, and writing the equations of the asymptotes. So let's jump in. So to make the equation look like this, remember we'll need two perfect squares. So our task is to complete the square with respect to x and y. So let's do that. We're going to gather the terms together that have x's in it. So we have 25x squared minus 50x. And we'll gather together the terms that have y's in them. So we have negative 4y squared minus 40y. And we're going to complete the square with respect to both x and y. But this 25 doesn't need to be involved in that process. So let's subtract 25 from both sides, and it will be out of the way. Now to complete the square, I want the coefficient of the x squared to look like a 1, so let's factor out the 25. Conveniently, 25 goes into 50 evenly, so the factoring is not a problem here. And I'm going to leave a space for the number that I do want. And here I need to factor out the coefficient of negative 4, being careful to factor out negative 4 from this term as well. Sometimes people make a mistake there and forget to factor out that sign. So we would have y squared plus 10y, and I'm leaving a space for the number that I want. So now here comes our process, or our step for completing the square. Remember, the number that goes here is half of the coefficient of our linear term squared. So half of negative 2 is negative 1. Negative 1 squared is 1. So we're going to put in a plus 1 right here. But remember, this isn't really a 1. That 1 is being multiplied by this 25. So we really just added 25 to the left-hand side. So I need to add 25 to the right-hand side as well. Similarly, right here, we are going to take half of 10, that's 5. 5 squared is 25. So we're going to add 25 right here. But it really isn't a 25. That 25 is being multiplied by this negative 4. So we really just subtracted 100. So that means we need to subtract 100 from the other side. And now let's continue. We should have perfect squares. So we have 25 times x minus 1 squared minus 4 times, and here's our trinomial that becomes y plus 5 squared equals negative 25 plus 25 minus 100 is negative 100. Remember, in standard form, let me bring this back, we need a 1 on this side. So we're going to divide by negative 100. And let's divide each term by that. And now notice this expression right here will be negative, and this one will be positive. So I'm going to write this one first. So I have y plus 5 squared over 4 over 100. 4 goes into 125 times, so I have a 25 in the denominator. So that those two negatives canceled, and we ended up with a positive. Now this term is next, so we have this negative, that becomes our minus. 25 goes into 104 times, so our denominator is 4. And we have x minus 1 squared, and that equals 1. So we now have the equation of the hyperbola in standard form. So let's move on now and just practice graphing, finding the coordinates of the foci, and writing the equations of the asymptotes. And I'm going to grab a new piece of paper so that we will have space for that. So here we go. And let's write the equation here. Again, it was y plus 5 squared over 25 minus x minus 1 squared over 4 equals 1. So let's start with center. Remember, the x coordinate of the center will be with the x, and the y coordinate will be with the y. So it's x minus the x coordinate, so my x coordinate is 1. And it's y minus the y coordinate, so that's really y minus negative 5. So my y coordinate is negative 5. So let's see, we're going to have the center at 1, negative 5. So I'll just move over 1 unit and down 5. 1, 2, 3, 4, 5. Here's negative 5 right here. And I'll just put that point there. There's our center. Now our y squared is first. We have a hyperbola that's going to be opening up and down. To find the vertices, we go in the y direction, the square root of 25 or 5. So let's do that. So from center, I go in the y direction, the square root of this number. So from center up 5. 1, 2, 3, 4, 5. Here's one vertex. And down 5. 1, 2, 3, 4, 5. And I'm down here at negative 10. But in order to have my hyperbola look right, I need the asymptotes, because they'll tell me how wide or narrow the hyperbola should be. I don't know if it's opening very wide or very narrowly, but we use this denominator to help us draw the central box, and that will allow us to draw our asymptotes accurately. So starting from center, I go in the x direction, the square root of this number. So from here, I'm going to go over 2 units. 1, 2. And from here, 1, 2. So if I label those so we can see where those are, this is over here at 3. This is at negative 1. This, by the way, was just at 1. So I'm going to draw a box that goes through each of these points. Right? Can't see it very well right here because the top of the box is right on the x-axis. But we draw that box because the asymptotes can be found by drawing the line that contains the diagonals. Now I did this kind of freehand, so they don't look perfect, but the asymptotes will contain this diagonal right here. Similarly here. And now I can draw my hyperbola. Remember, the asymptotes are graphing guides. Sometimes people just draw some shape that's within those asymptotes, but they don't actually use the asymptotes. Remember, your graph should go toward the asymptotes. That's why we put them in. So there's one branch of the hyperbola, and here's our other one. So there's the graph of this particular hyperbola. The next step was to find the foci. Remember, the foci are always inside the branches. So the foci will be here and here somewhere. I don't know where those are yet, but what I do know is that the distance from center to focus is C units. Because I know this center right here is at 1, -5, I just need to find C, so I can go up C units and down C units, and I'll have those foci. Well, remember the A squared, or let me say this first, the relationship we know is A squared plus B squared equals C squared for a hyperbola. For me, I like to remember if this is a minus, this is a plus, as in the case of the hyperbola. In the case of the ellipses, this is a plus and this is a minus. But let's keep going with this one. Remember, with the hyperbola, the A squared is the denominator in the expression that has a positive coefficient. So it's the denominator of this one. So my A squared is 25 and my B squared is 4. And now I have an equation to solve. So I have C equals plus or minus the square root of 29. So our C value is really the positive square root of 29, but I like the plus or minus there. It reminds me that I'm going to go up square root of 29 and down square root of 29. So from this point, that center, I'm going to add that C value to the Y coordinate. So my foci are at 1, -5 plus the square root of 29. That's up here. And 1, -5 minus the square root of 29. And last, we're going to find the equations of these asymptotes right here. So let's write that down. So the asymptotes. We know that they pass through the center of the hyperbola. So they pass through the point 1, -5. And we also can see the slope. The slope is rise over run, and we can see it from our box. Remember, it was up 5 and over 2, and those numbers came from the denominators of these expressions. So up 5 over 2, and up 5 and left 2. So a positive 5/2 and a negative 5/2. So remember how to write the equation of a line if you know a point and a slope. You can just use your point-slope form. Let me write out that formula for you in case you haven't used it for a while. It's y minus y1 equals m times x minus x1, where x1 and y1 are the point and m is the slope. So for this problem, I would have y minus the y coordinate equals the slope, which is 5/2, times x minus the x coordinate. And this is the equation of this asymptote right here. Now for this one, we have the same equation, except our slope is negative. So it's y plus 5 equals -5/2 times x minus 1. And those are the equations of the asymptotes. Now those are in point-slope form. If you needed to put them in slope-intercept form, no problem. You could distribute and manipulate the equation. But often this is far enough. It just depends on what you're going to do with those equations. So we have done it. We have our graph, we have our foci, and we have our asymptotes.